PowerPoint. This is at the end of the Chapter 4 PowerPoint. It's stuff we already know, but I feel like looking at it anyways. So, Boolean OK is equal to false. X is equal to 6.5. Y is equal to 10. So let's evaluate the expression. X not equal 65 or not OK. Well, let's figure that out. X not equal 65. Is that true or false? Excuse me, 6.5.
False. False.
Yeah, because it is. So false or and not okay. Is that true or false?
False.
True.
That's true, right? And so what is false or true?
True.
Yeah. Right? So that's how we evaluate that one. Let's come and look at this one. Oh, and this is even sillier because we're throwing the word true there. And we could pretty much almost rule that one out. But, you know, so true and 12.0 less than x plus y. Well, addition has a higher precedence than less than. I probably would have worded this with parentheses. But just do the math before you start comparing less thans and greater thans. So x plus y is 16.5. Is 12 less than 16.5?
Yes.
Yes.
So that's true. That's true. So true and true is true.
True.
Let's scroll down and see if we got them right. Ooh, and then problem 3. I guess we make that one up. All right. See the operator precedence table. Addition is highest. Is there one? Oh, it says to see it. It's in the book. All right. So anyways, parentheses are always the highest precedence. Adding or subtracting after the variable, like x plus plus, x minus minus, that's the second highest. And, you know, and then you got multiplication and division and modulus, and then you have addition and subtraction. And then later on there we finally have the relationals, right? So all the math is greater than the relationals, the less thans and the greater thans and stuff like that. And then ands are higher than ors, because ands are logical multiplication and ors are logical addition. Then there's the good old ternary, the goofiest one of all. You know, x is equal to 6.5, y is equal to 4, z is equal to so, what will z equal? How do we solve that? Well, you do everything before the parentheses. Is x greater than y? Yeah. So, is it going to equal the first value or the second one?
First.
It's going to equal the first, because that's what the conditional operator means. If this was false, then y would get copied into z. But it's true, so x gets copied into z. That's enough of chapter 4. We're going to begin chapter 5, which is not on the exam. I say we stopped on page 24, but I thought we were done with it. Let's go see what 24 was.
You had that comment at the start of class last time, so we went to the end.
We went to the end. Good. Okay. So that wasn't last comment. All right. getting closer to object-oriented programming, using pre-built methods. If you know what a function is, you know what a method is. Except that a method is something that's part of a class, meaning it is attached to data, most commonly. So, the API library, API headings, the math class, wrapper classes, string methods. We've kind of hit some string methods before already. And then formatted output with the printf method. Now, I've been making y'all use printf all along, so we're going to be able to scroll past that pretty quickly. And that means that it's likely to show up on the exam since we've been using it a lot, but you know what it's for. Print %f will print a floating point number. Print %d is an integer, and so on. But if you had to, pop open chapter 5 and look up the answer. Anyways, the API library. If you're going to write a program and you're trying to figure out a problem, check to see if there's a pre-built class that meets your program needs. Like if you know what a stack is, and your specs say implement a stack to store the data. Your first impulse should not be, okay, I'm going to write my own stack. You need to have a really good reason to write your own stack because Java comes with classes that you can use to implement a stack, and it comes with a stack class. So if there are pre-built classes, then use those classes. Don't reinvent the wheel. For example, you don't want to calculate, you don't want to write your own code to calculate the tangent, right? Or, square root. Yeah, we could figure out the square root pretty easily, but, you don't want to write code that will do that. You certainly wouldn't want to write code that would figure out pi. Instead, you would use the stuff that's part of the math class. Now, the math class is a special class because it's built in. It's automatically included. We don't have to add an import up at the top to import the math class, I believe. Anyways, we'll find out very soon. So for example, user input is a complicated task, right? If we had to read the keyboard ourselves, store that in some kind of buffer so that we could then pull it out in a tokenized fashion, and then convert it to an int or, like next int, next one, that would take forever. Instead, the scanner class does all that for us. When we need the user input, we use the scanner class. Math calculations can be complicated. The math class handles those calculations. When you need to perform non-trivial, in other words, not just addition and multiplication and stuff like that, use the math class's methods rather than writing and using your own. You could. Every, math thing is a formula that you can probably implement, using loops and, things. I don't know how you would implement, tangent and things like that. I have no idea what those formulas are. So Java's pre-built classes are stored in what's called its class library, more commonly known as the API, the Application Programming Interface. So the classes are not part of the core language. So for a language to use an API class, the class first needs to be loaded. It needs to be imported into the program. So to use the scanner class, you have to add and include up at the top of your program. We've been lazy and letting NetBeans do that. But every time we use a scanner, if we scroll up to the top, there would be an import java.util.scanner. The java.util is the package. Remember our package statement? We can create our own packages. What is a package? It's a group of classes. Right now, we've only been creating one class per project. But we could create, 20 classes in a project. And we might package them all in the same package. We might package them into 2, 3, 4 different packages. So the Java util package contains quite a few general purpose utility classes. But the only one we need for now is the scanner class. However, we're awesome and we're going to go and look up what other kind of stuff might be in java.util. I could Google that, or I can just launch NetBeans and then type java.util and then get a list of all the methods. I'm going to Google it while I'm waiting for NetBeans to load. Java.util class. That's the package, java.util. Let's go take a look at the kind of stuff you can do. Now it's got a whole bunch of stuff that we don't understand. Comparators and collections and maps and stuff like that. A lot of stuff that you would learn about in advanced Java.
Are those for object-oriented?
Yep. Everything in Java beyond primitive data values like ints and floats and whatever is object-oriented. And so the classes are implemented as object-oriented stuff. So we've got a Gregorian calendar class. We've got a hash table class. We've got a properties class. We have random. We've been using random. We've got a scanner class. Hey, I mentioned stack. There's stack. We've got timer if we want to schedule things to happen in the future. Right, there's all sorts of things inside java.util, a lot of which we're not going to use. Arrays. There's an arrays class which lets you manipulate arrays. And when I said everything is a class, I do not believe that arrays are classes. Could be wrong on that. We'll figure that out real quick. So anyways, lots of things available in there for us to play with, to learn. And all this stuff is stuff that you might be tempted to write your own if you grew up learning a programming language that didn't come with a huge application programming interface. So like when I was taking college courses, I had to write my own list and stack classes and stuff like that. And we could still take the time to learn to write that kind of stuff, and maybe we'll write, our own stack class or something like that. But, it's more important nowadays to be able to use this stuff rather than to know how to write it. You have to know enough about it in order to use it, but you don't necessarily need to know enough that you could sit down and recreate it quickly. So some classes are so important that Java automatically doesn't import for you. Those are in java.lang. For example, the math class. We don't have to import the math class to perform math functions. So we don't see it, but the Java compiler acts like the first line of the program is import java.lang.star. If you use an asterisk in an import statement, it means bring all the classes from that package. So up at the top, whenever we create an application, we could just add import java.util.star, and then when we wouldn't have to add one for the scanner or for the stack or stuff like that. Now the reason I don't do that is because it's useful information to be able to scroll up to the top and see what imports were added. Right? If I see import scanner and import stack and import timer, I know, oh, okay, this chunk of code uses a scanner and it uses a stack and it uses a timer. But if I just did import java.lang.star, then I don't know what in the heck it's using, right? I have no preconceptions as I scroll down the code. So your list of imports serves as a form of documentation. So I would rather list them all rather than do a .star, especially since NetBeans makes it so easy. Now, if NetBeans didn't make it easy, I'd be a lot more tempted to do it. So to use an API, you don't have to know the internals of the class. You just need to know how to interface with it. To interface with a class, you need to know how to use the methods within the class. So if you're going to use the scanner, you better know that there's a next, and that there's a next line, and a next int, and a next double, right? And then I showed you a couple of additional ones, like has next double, right, and stuff like that. If you have those ideas and can look them up, right, okay, well, I want to get an int out of it. Not every language has a way of pulling int out of user input. And sometimes you have to convert it, yourself, like we've seen in the Python language. It just input returns a string, and you have to convert that string to an int. Whereas C++ automatically, magically does it for you, even if you don't know that you're supposed to call like a next int or whatever. It just does that for you automatically. Well, Java's kind of between the two, right? It turns the string input into an int or a double if you call next int or next double. And if we don't know how to use something, we just look it up, right? So if I'm typing some code in, new project time, are we on K? I think we're on K. Make absolutely sure of that. In fact, while I'm thinking of it, I'm going to make that folder right now. All right. So that way I don't have to remember to do it at the end of class. Anyways, here we go. I don't know what a scanner does. I'm going to create create one, scanner SC is equal to new scanner, system.ym, system.in, alright, I better add my import for it. I'm going to show you that bad habit. You just scroll up, yeah, I'll let NetBeans do it. I was going to use java.util.star, but we don't use too many classes out of java.util right now, except for the scanner. Okay, so I want to see what so-called methods are part of the scanner class. A scanner, excuse me, a class can be thought of as a collection of data and the methods, the functions that act upon that data. Now, not every class has to have data. Not every class has to have methods. But usually, and especially the ones you write, they'll usually have some data elements involved, and they'll usually have some methods that interact with that data. So somehow the scanner class has some data inside it which holds the buffer from the keyboard. And it's got methods that'll pull that out or interact with it. Anyways, I'm going to type in sc dot, and I'm going to see a whole bunch of methods and a description of them. So like has next. If I click on has next, it tells me what it does. Returns true if the scanner has another token in its input. It will block while waiting for input to scan. The scanner does not advance past the input. It doesn't touch the data. It just checks to see if there's any coming down the pipe. Now I can't imagine why we'd want to use this. But has next double and has next int and stuff like that, for writing loops that'll validate, your data, make sure that you entered good data. Those are very useful. Has next pattern. Alrighty, I've never used this. I guess what it would do is whatever pattern you would specify, it would tell you if that was sitting there waiting to be read in. Well, what's a pattern? Regular expression. Now honestly, I've only ever learned enough about regular expressions to solve the task that I was trying to solve at that moment, and then I immediately forget everything about them. But you can Google up regular expressions if you want. Java regular expression. And find some documentation over it. Look at the Oracle documentation for it. Here's a tutorial. I guess I ought to learn them. And they look something like, give me some examples. Stuff like that. Yeah, I don't know what that means. But same kind of thing as that asterisk. Where the asterisk is a wild card, meaning match anything. This is very specific. Remove every white space between a word, character, and a period or a comma. Now, honestly, I don't see how that does that at all. And I would learn it if I needed to use that pattern. So, okay, so we can look up documentation on that kind of stuff. If I want to view the web page about it, I can actually type its name in as a function. I can double click on the name, right click, and do show Java doc. No, I can't. Can I highlight it and hit F1? Yeah. That's not telling me much either. I have gotten better results from this in the past. Why isn't it working? Alright, as soon as I put the parentheses, it worked. And it takes me to the web page about it. So I can kind of poke around. I find out what class it's in, how you call it. I might get some examples. I'm not seeing a lot of examples. If it returns an exception or not. We haven't learned about exceptions yet. So on. I think I'm going to type in my definition. A class is a collection or a group of data and methods, functions that work with that data. Is that 100% true? No. Not all classes have data. Not all classes have methods. And some of the functions don't work with the data. That sounds weird. But like if you call tangent or if you call square root, there's no data inside the class that is being used to solve a square root. It just does some math. But this is a working definition that we will play with for now. And to be more specific, we should say that a class is a definition of a collection of data. Because it's not actually the data, but it's a definition of a collection of data and methods that work with that data. Now the book's not going to tell you that exactly, but took that away in your head, and if I ask you for a definition of a class, I'd much rather you give me that than to look it up in a book and give me a description that you find in the book, or if you copy and paste something from Oracle. Please memorize this. This is true in spirit. This is, you know, just want you to have that tucked away in your head. So you need to know what kind of arguments to pass to it and what kind of value it returns. For example, if I call has next double, what is it going to return? Is it going to return a double? No, it's going to return a Boolean value that I then use inside of an if for a while or something like that. And if I didn't know what kind of thing it returned, I'd have a problem. But I can always hit, you know, highlight it all and do show Java doc, and it'll tell me what it returns. Here's what it looks like. Returns Boolean. Something else would return a double, right? If you call next double, it's going to return a double, so you can do some math with it or whatever. The word public we will kind of talk about in a little bit. So you look up, you need to know what it takes as a parameter in order to know what arguments to pass with it. Now has next double doesn't take any parameter. Neither does next double. The math classes take parameters pretty much. Right, you're going to calculate the square root of something, you have to pass in a number. So the standard way to show that information is to show the method source code heading. Let's see if they give an explanation of that. Okay, so for example, the source code heading for the scanner class nextInt is this. Public int nextInt. This tells us a lot of information about it. It tells us how it can be called. There's that public keyword again. What kind of data it returns, and what kind of data, what kind of argument you have to pass in to fill in the parameter. There are no parameters here, so you don't pass in any data. You pass in no arguments. I guess I'm going to use those terms often enough that I need to define them. Parameter, a variable defined within the parentheses of a function header that accepts a value. And then the argument is the data between the parentheses when that function is called. And I messed up. It's not actually a function, it's a method. Those terms are almost interchangeable, but not quite, because a function is something that's not attached to a class. And in this language, there are no functions, there are only methods. In other words, if you want to create a function, you have to make it part of a class. And you could just make it part of the main class, and then boom, problem solved. C programmers, though, may be used to the idea that you can then just go up to the top of your code and add some functions to the very top of your code and it'll work. No, in this case, you're either going to be adding your functions to the main class, or you're going to create another class in your project to hold those functions. Methods. Methods, functions, functions, methods. So the math class. Here's a couple of functions. ABS returns the absolute value. Absolute value just means the the magnitude of the number without a sign. So the absolute value of 10 is 10. The maximum value of negative 10 is 10. There's two different versions of it. One accepts an int and one accepts a double. Why would they make two different versions? Because if you pass in an int, if you pass in negative 10, you want to int back out. Right? If I did this, x is equal to math.abs of negative 10. I don't want to have to declare x as a double in order to get that answer back. So they provided two versions. They provided a version that accepts an int and returns an int, and they provided a version that accepts a double as its argument and returns a double. That is known as method overloading. That sounds scary. Captain, the engines are overloading. It's not scary. It just means that there are more than one version of the method that accepts different types of data. And it's a very common thing in the languages that support it. Because otherwise you're stuck doing things like this. And don't type this because it would be dumb. The absolute value of a double, right? And then later on, y is equal to math dot absolute value of an int, right? You create a different one for each kind of data you want to use. You could still do that. But if the language supports it, why not make it so that the same function name, accepts different values? If you pass it an int, it treats it like an int. If you pass it as a double, it treats it like a double. So overloading. Methods that accept, or methods of the same name that accept different types of data. Why do you overload? To make them easier to use. You don't have to remember to use one version of square root to take a square root of an int and another to take a square root of a double. Now honestly, there's probably only one version of square root. I'm not sure about that. We could find out. But certainly absolute value we just saw comes with multiple versions of it. Max compares two values. And then there's another version of max that compares two values and returns the largest of the two. And again, ints, so to return an int, and doubles, so to return a double. And you don't need to know the difference between the two. It just works naturally. You call max and you don't care whether you're passing it ints or doubles. More of them. Min. Min takes the smaller of the two. Right? POW raises something to the power of something else, right? Like an exponent. Random. This is slightly different than the random function that I think we used. Have we used random in this class yet?
No.
Okay, well. This is slightly different than the random class we have not used. What it does is it returns a value between 0 and 1. But the 1 is not inclusive. So it returns a decimal, right? Like you call random and it gives you a number 0.107354. Why don't we play with that just so that I'm making y'all type something. Let's ask how many random numbers they want and then print out that many random numbers. So int how many equals scanner.next int, but I didn't tell them what to type, so I'm going to put a print statement before that. System.out.println how many random numbers. If I'm going to make this code really awesome, I would use hasNext to make sure it doesn't crash if they type in bad data. It doesn't take that much extra typing to implement that. So here's what I'm going to do. I'm going to just declare how many, and I'm going to give it a initializing value, 0, whatever. NetBeans may tell me that that initial value is ignored. That's okay. I can always go back and remove it. So while sc dot hasNextInt equals false, then call sc.next. Just wipe out that value. And then now we can do how many is equal to sc.next. As a matter of fact, we didn't even have to declare this before that, did we? We could have declared it here. But whatever. I'm going to make sure that works. I've never written it in such a succinct way, so I'm kind of interested if that works. All right. It did work, but it didn't print an error message, right? So I should print some kind of error message, like system.out.println. Please, whole numbers only. How many random numbers? I type in something. Please, whole numbers only. 1.1. Please, whole numbers only. Okay, and then I give up and I type in a whole number and it worked. All right, so we know how many numbers. Let's make a loop that'll print that many numbers out. I think I'll just use a for loop. I like for loops. I use them for as many things as I can. So, for int x or int I, I used to like I, for iterator, but I'm tending towards x nowadays because it's easier to read on the screen. Let's start x is equal to 0, x is less than how many, x plus plus, and let's just print out some random numbers. System out dot print line parentheses math dot random parentheses in parentheses like that. Now, sure, we could store those random numbers in a in a variable before we print them out. We could sum them up. We could do cool stuff like that. But how many random numbers? I want 5. Let's scroll up and see if I've got 5 random numbers. There they are. Now the random numbers are going to be between 0 and up to, but not including 1. So they might be 0.999, out to 15 digits, but they'll never actually equal 1. Now a lot of programming languages, or way back when, that kind of random number was a popular thing to use, and because the libraries generated it, and then you had to turn it into a whole number. And it was a pain to do that. It was a pill to do it. You'd multiply it by a certain value, and then you'd modulus and stuff like that. But thankfully, there are classes that handle that stuff. We don't have to use a class. We don't have to use that fractional number to try to turn it into a number between 1 and 6. Right? Because if you're writing a dice game where you roll dice, you're playing Yahtzee or something, you wouldn't want these fractional numbers, 0.253475, and then figure out how to convert that to a normal, a different number. A whole number, an integer. It's possible. You can look it up, but nah. Alrighty, and then there's round, and then there's square root, and so on. Okay, so let's just do some of these. Int x. X is equal to math.min of 10 and 20. That's going to return 10. I'm not going to even print it out. Math.max of 10 and 20. That's going to be 20. X is equal to math.abs of 10. That's going to be 10. X is equal to math.abs of negative 10. It's also going to be 10. Now we could use sine and cosine and tangent. The only gotchas to that is that the methods are expecting your input to be in the form of radians and not degrees. And yeah, maybe you were paying attention carefully enough in trigonometry to remember how to work with radians, but honestly it's been a long time for me, so I don't really remember. Instead of taking the tangent to 45 degrees, you have to convert the 45 degrees to the equivalent number of radians, and then you could take the tangent of it. Now there's a function for that. So I'm going to do that. Double degrees is equal to 45. And now I need to find the function that'll turn it into the radians. Double radians is equal to math dot, oh boy, we got a lot of them. Two radians. Whoa, that's not hard. Math dot two, oh, whoopsie. Math dot 2 radians degree. And now I could figure out the tangent of that. So double tangent is equal to math dot tan, and pass in the radians. Now I saw a different version of tan called tan H. I don't know what that is. I'm just going to type it, highlight that, go to Java doc, find out what tan H does.
It's the,
Hyperbolic. All right. That's way more math than I know, so I'm proud of you for knowing that. Okay, so
I had to use it like a year ago, and
Oh, yeah. All right, so now I can print this stuff out, just for funsies. System.out.println, quote, the tangent of %f, because we're dealing with floating point numbers, degrees, is %f. And by the way, this needed to be printf, and I always wind up doing this. I wish that print line also did that formatted stuff, but anyways, I need to change that to a printf. So after the quote, comma, and I want to print out the degrees to fill in the first placeholder, and the tangent to fill in the second placeholder. It would also be nice to know how many radians that is. And a radians is just defined like in pi, rather than dividing the circle up into 360. So for giggles, I'm going to print out systemout.printf. By the way, that is %f radians. In quote, comma, radians. Now I've made a mistake. Not a big one, but printf doesn't automatically go to the next line, so I need to put \n at the end of my formatting strings. All right, if I played my cards right, we'll find out what the tangent of 45 degrees is. It's 1. Yep, sounds right. Why? Because tangent is rise over run. And a 45-degree triangle would have, a rise of a certain amount and a run of the same amount. Yeah, yeah. All right, so that looks good. And by the way, that is 0.2853. Alrighty, so I'm just going to type in something out of my own curiosity. Nope, that's not it.
No, I was right. It's 32.
So unit of angle, a radian is a unit of angle equal to the angle at the center of a circle whose arc is equal to the length of the radius. Forget it. So we have used a lot of functions in the math library. Something to notice about the math library that is very different from the scanner library. I'm just going to put any kind of, don't even type it if you don't want to. Int whatever equals math.pow 2 to the power of 3. Notice a difference between how I used, because it's not returning an int, excuse me. Great, I love it when I'm typing a simple example and I get it wrong. Alrighty, so notice the difference between how we called math.pow and how we called hasNextInt. What's a couple of differences? Well, I see one difference. That's a lowercase variable and that's an uppercase variable. Well, why is that a lowercase variable? Because it's one we created. We created that object. We did not create a math object, right? So we used some functions that were inside the math library, but we did not have to create a math object, a math variable in order to do them. But the scanner, we did have to create an object. We had to create a new object. That's why I'm highlighting the word new. So some methods do not require you to create an object, and some methods do. The ones that do not require you to create a new object are called static methods. The static method does not require the creation of a new object. So that tells us that all these math functions are static functions. We did not have to create a math object in order to use them. Meanwhile, the scanner methods, we had to have a scanner in order to call sc.hasNextInt and sc.next. Now, why would we bother caring? Well, the reason why is that the math class doesn't need to track any data between calls, right? You pass it some input, it does a math calculation and returns it. Nothing is saved between those two things. It doesn't have to maintain any state information, right? The fact that we called math.pow doesn't set up something else for a later call to the math library. So it is stateless. It contains no data. And if a class contains no data, there's no reason to instantiate a math object. We're not keeping track of any data. Now the scanner, on the other hand, does keep track of data, right? It pulls data out of the keyboard and it keeps the data in a buffer so that you can call functions on it and stuff like that. So the scanner class does have to maintain state information. That's why we have to create an object before we use it. So that's the difference between the two. Some classes you won't have to create an object in order to use them. Some classes you do. You basically learn that by experience, but the real reason is whether the methods in it are defined as static or not. If it's static, it's known as a class method, meaning that you don't have to create an object. It's just a class method. It's attached to the class itself. It's called by invoking the name of the class. Right? So when we called math.pow, we use the name of the class. And in Java, you're supposed to capitalize the first letter of every class. Now, if it's not declared as static, if we deleted that static keyword, then that makes it a reference method. There's probably another term for that. That means that you have to have a reference to it. You have to have an object before you can call it. And so if you have an object, you created that object. And you're supposed to create all your variables lowercase. So when you're looking at a call, if the thing in front of the dot is lowercase letters, you're pretty sure that it's not a static method, that it's not a class method. If you don't know whether that method needs to have an object created or not, you just look it up and see if it's declared as static. Math.pow, well, let's look it up, show the Java doc, and it tells us that it is declared as static. Static meaning class meaning that we call it by using the name of the class. And if we call it by using the name of the class, we don't even need an object, so we don't need to create a variable. All right, that's more object-oriented programming than this PowerPoint goes into, but I don't care. We got to learn it. Why not hit it now, and then the next time we see it, we'll know it even more. All right, so round. There's one that'll round it to the closest number, right? So round 3.1 will round it down to 3, but round 3.9 will round it up to 4. Well, not only are there round functions, there are ceiling and floor functions, right? So if you call ceiling of 3.9, it'll round it up to 4. But if you call ceiling of 3.001, it'll still round it up to 4. It'll round it up to the next whole number. And then there's a floor function, which will round it down to the next whole number. So rather than 0.5 being the division between rounding up and down, if you call floor, you know it's going to round down. And if you call ceiling, you know it's going to round up. Let's get the name of those functions. I'm going to delete math.pow and make this math dot. Ooh. Am I wrong? Where's my ceiling function? Well, there's floor. Well, there's floor. That's what I was looking at. But where's ceiling?
Seal? Is it just seal? Seal.
But did you see it?
I saw
Oh, it's right there. Why didn't I see it when I started typing it? Seal. Right. Okay. So the ceiling of 3.1 is 4. And then whatever is equal to math.floor The ceiling, the floor of 3.1 is 3. And now I'm going to change those to 3.9. Right, so this, the ceiling of that is 4. The ceiling of that is 3. But, excuse me, the floor of that is 3. But if I change this up to 3.9, the ceiling of it is still 4. And the floor of 3.9 is still 3. Doesn't look like they did a lot of difference, but if we use round instead, then it differs. So I'm going to copy this stuff and paste it for round, right? Math.round of 3.9, well, that's where it splits at 0.5. If it's 0.5 or greater, it goes up. So what's round of 3.9?
4.
Right. But round of 3.1 would be 3. So I'm going to move that there. Delete the word double. And I'm going to take this one and paste it up here and say that the round of 3.1 is 3. Well, all right, like that. So, you know that now. By the way, a hack for getting the square root of a number is just to raise it to the power of 0.5. And how to get the cube root of a number is to raise it to the power of 1 over 3. How to get the quarter, whatever, anyways, it works like that. So notice the static modifier. All of the methods in a math class are static, also known as class methods, which means that they are called by prefacing the method's name with the name of the class. So math.abs is part of the math class. Why can I not highlight? Oh, okay. I guess I was in actual preview mode. I'm just going to steal that stuff and paste it directly into my notes, because that's important enough that I'm not going to memorize it. And then the corollaries, if it's a non-static method, you can't call it by using the class name. If there were any non-static methods in the math class, in order to use those special methods, the non-static ones, you'd have to create an object. So it is legal to pass an integer value to a method that accepts a floating point number. So math.pow is defined in such a way that it's expecting floating point numbers there. They didn't overload it to write a version of POW that accepts ints and then accept floats. They just decided it was easier to write one that only accepted floats. But that doesn't mean you can't pass an int to it. An int can be converted to a float cleanly, right? 3, okay, well 3.0. That's my floating point version of it. A common use of computers is to model real-world activities that rely on random events. Computers are good at generating random numbers, except they're actually pseudo-random numbers. Pseudo meaning not true random numbers. And then being able to repeat the random events many, many times. Like if you were going to write some kind of microbiology simulation and you were tracking a number of bacteria and you didn't know exactly which bacteria was going to divide at which point. Or better yet, if you're using, writing a physics, chemistry where you have some decaying uranium, you don't know when that particular atom, that particular molecule of uranium is going to split or not. It's random. Some of them will split now, some of them will split 10 years in the future. So, if you were going to write a simulator, you would be generating random numbers. And based on the chance that that cell division was going to happen, or that atom was going to split, it would split or not. But pseudo-random means that it will follow the same sequence every time given the same starting number. Now some functions, some languages, some platforms always start at the same random number. And I'm thinking C++. If you call random on C++, it'll give you this one number. And then the next time you call it, it'll generate a second number, but that second number is based on that first number through some mathematical process, which, modifies it. And then the third one follows from the second one. The random function uses the last random number to generate the next one. So if you ran that program 2 times in a row, you get the same exact sequence. That's because they all start with the same seed value. You have to give it a seed value. Now Java randomizes the seed value to the best of its ability, so you don't have to set a seed before it starts going in there. But there is a way you can specify a seed if you're using a random class, and that is if you want to generate the same sequence of random numbers every time. Like, what if you write some sort algorithm and you're testing it with random data and you find, oh, I found a case in which it fails. Well, you want to be able to force it to accept the same sequence of numbers every time. So you might want to set a seed. And then once you solve that problem, once you figured out what was wrong with that particular sequence, then you comment out the seed and it'll generate, what look like random numbers. Now there's no way to make a computer like this algorithmically create a true random number. So quite often people use time functions to give it a seed, like the number of seconds since midnight, or the number of milliseconds, since midnight or whatever. And that way, you're most likely going to get a different seed value unless you just happen to run it at the same, exact second every night. So math contains pi, math.pi. May as well mention that as well. I'm going to come down to NetBeans, and I had a whole bunch of lists of these things. But, it needs to be a double. So double pi is equal to math.pi. Would I ever store the value of pi in another variable before I used it? No, I'd probably just use a constant. It's not like pi is supposed to change in the middle of your program, right? It's a mathematical constant. All right, we're getting close to the point where I want to flip and start talking about the exam. Last thing I want to talk about before we do that, though, are the wrapper classes. Not like wrapper like MC Hammer. Wrapper as in they give us additional functionality that the primitive data types do not. Right? Primitive data types, a number is a number. Right? It doesn't have any methods. Now that I have a variable called x, I can't type x dot and get a list of methods for it. Because it's not an object. It's just a piece of data. It's a primitive value. It's an int. But what if you need to do other things with it? Like what if you need to convert it to a string? Well, you would need to use the wrapper class. The wrapper class for int is the whole word integer. So I could say integer x is equal to new integer parentheses. Oh, here I am reusing a variable name. I can't do that. So I'm going to call it x2. Integer x2 is equal to the new integer version of x. See what I just did? I took x and I used it as input to create an integer, not an int. We've been calling them integers the whole time, but they're really ints. That's the specific keyword for it. And now we have souped up superpowers. x2 dot. All sorts of things. And we want to convert it to a string. That's nice. We could call, x2.toString to store it in some kind of string for whatever purposes. String s is equal to x2.toString. Like that. Except strings are classes, not primitive data types. Notice that this did not start with a lowercase letter. This did not start with a lowercase letter. This did. Primitive data types all start with lowercase letters. All the rest of the data types, including the ones you create, are going to start with an uppercase letter if you follow Java's naming convention. Strongly recommend you do. So that's why this one starts with a capital I, and this one does not. Now, there are other wrapper classes. Double D. Notice it's got a capital. That's how you tell that it's a wrapper, rather than just being a pure math number. Float, F, right? Long, L, and so on. The reason you use the wrapper classes is because sometimes you don't want to just do pure math on a number. You want to convert it to a string, or you want to convert it from a string, or something like that. So what if we had D, and we wanted to pull it out of a string? D is equal to double dot parse double S, like that. We just took a string, and we passed it in to the double wrapper class's parse double function to be converted into a double. Now honestly, we didn't have to declare that variable to be of type double to receive it, because parse double returns a D with a lowercase d. So I'm going to do this, double D2, right? So this thing returns double with a lowercase d. And there are other versions of parse. There's integer.parseInt, there's float.parseFloat, there's long.parseLong. Now why would you use these parses? We can just always use next int, and next float, and next double. But that's not true. If you're writing a graphical user interface application and you put text fields for the user to type into, you're always going to get a string. Like if you let the user fill in their age, when your application gets that age is in the form of a string, and it's up to you to convert it to a number to do math with it. Make sure they're old enough to apply for the credit card or whatever. So you have to use parse in order to turn the string that they typed in on the graphical user interface into a number. So that's why these parse functions exist. We cannot convert a string just by simple casting. I can't do this. Int age is equal to parentheses int, 100, because we're going to use old. That doesn't work, because a string is not a compatible data type. It's not a numeric data type that you can just kind of twist its format a little bit to store it in another number. It's completely different, right? Because a string can hold anything, not just a number. It can hold, Russian characters in it. And so you can't cast a string to a number. You have to parse it. That's how you convert strings to numbers, is with one of these parsing functions. So you use parse methods to convert string data to numeric data for math processing, whatever. You cannot use casting to convert from strings to numbers. So something to note here. Here's toString. It's part of the integer class. Here's parse double. It's part of the double class. One of these is a static method, and one of these is not. Is parse double a static method? The way you remember if it's a static method or not is if you didn't have to create an object in order to use it, it's a static method. Did we have to create a double with a capital D before we called parse double? Does this have an uppercase letter? That's an uppercase letter. That means it's a class method. That means it's a static method. We did not have to create. So this is a function, these wrapper classes have both static classes and static functions and non-static functions. This one, on the other hand, toString, right? We have to have some data to convert to a string, right? Otherwise, just calling toString by itself doesn't make any sense. So it has to have some data. It starts with a lowercase letter. That means that it's a variable and not a class. That means it's non-static. static functions if the thing before the dot begins with an uppercase letter. It is a static method. If the thing before the dot begins with a lowercase letter, it is a non-static method. And I'm going to put in parentheses that a static method is also known as a class method because you call it by the name of the class. I'm forgetting something, and it's okay, especially since this chapter is not talking about it. Enough. Let's stop there. If you want to upload anything, and please do, if you, even if it's just a note card saying that you were here in class, there's a folder for it. And let's do a little bit of review. Your best review is just to take the quizzes. However, there may be stuff we did in class, right, that aren't on the quizzes. So if you run into a reference to something that's not in a quiz, just look at our notes. You want to make it easy on yourself? I'm going to make a folder where you can upload your own notes into. And you could paste all your notes into a single document and then just open it up and do a Control F. But let's go ahead and do that. Make a notes, your own notes folder. That way you can reference stuff. You can upload any material in there that you want. So it is totally fair game for me to put stuff in the lectures even if they're not in the quizzes. I try not to do that, but it's fair game. And you folks who are taking C++ at the same time, there's a lot of overlap in the early material, right? Integers or ints, depending on, regardless of the language. Floats are floats, or statements are or statements, truth tables are truth tables, right? All of that stuff is common between languages. So is Java case sensitive?
Absolutely.
Absolutely, yeah, I keep talking about it. Does this thing start with an uppercase letter? It's obviously case sensitive. How many bits are in a byte? 8. If you have a flow chart and you have an if statement, how many branches are there going to be off that if statement? Let's draw it. No, well, I'm not gonna. But you have a diamond, and you have one that's a true.
So too.
Then you have another one that's false. So yeah, two ways out. So a if statement can branch off into two directions, representing true or false. Is it forbidden to have nested loops, one loop contained within another?
No.
Absolutely not. Can you have nested if statements? Yeah, of course. In a this is almost a trick question, and I almost feel like deleting it. But in a well-structured program, it is acceptable for program flow to return to a previous conditional statement via a loop. It sounds weird, right? But yeah, it is. It's totally legal for a statement, you know, just like this. If you have, here's our code. I had a loop here, right? So if I then printed something out, system.out.println, right? So our program flow went down here, right? It ran that statement, it ran that statement. Is it legal for it to go back to this statement again? Yeah, not only is it legal, it's going to be forced to happen if.
For loop, yeah.
Yeah, so loops allow us to go back to previous statements. Alrighty, my little Bluetooth indicator is fired off. Good programming practices. Do we like to go to new lines for a terminating brace, or do we normally stick them like that?
We don't want to go to the new line.
We want a new line. Is it a good idea to put your name up in a prologue?
Yes.
Sure.
Yeah. Is it a good idea to indent your so-called subordinate statements, or do we like our code to look like that?
It's really like it was in.
We want to indent subordinate statements. Do we save space, usually, by putting multiple statements in the same line? Do we feel like doing that?
No.
No, we don't feel like doing that. You can.
It's not as readable.
It's not as readable, right. So it's just not recommended. Do we need to include a comment at the end of every line of code?
No.
No.
Nah, that's too much. If we were writing assembly, sure. Should variable identifiers be as short as possible? Right?
Yeah.
No, your variable name should make sense, right?
Yeah.
Yeah. How many is a better variable name than H? Do I use a lot of single letter variable names? Yeah, just because they're easy to type. But if it actually represents something important, like a patient's temperature or height or weight or something, you just use X and Y for height and age. Use height and age. Alrighty. This is a way back that we haven't mentioned in a while. But if you have two strings, S1 is equal to, whatever. And you have string S2 is equal to whatever. Is this how you compare them?
No.
Not in this language. That works in C++, Vincent. But doesn't work in Java. What do you have to do to compare two strings in this language?
You have to.
Isn't it dot compare or something like that?
Yep, dot. Yeah, you can call dot compare or you can do dot equals.
Is there a compare state?
There is,
Okay.
and what compare does is it returns 1 if 1 is greater, it returns -1 if 1 is smaller, and it returns 0 if they're equal. But if we just want to see if they're equal, call dot equals. And there's another version of it, equals ignore case, right? Because sometimes you don't care. I'm skipping things like modulus. Know how to create a scanner, right? Just what's a line of code that creates a scanner. Know how to print something, right? System.out.println, that kind of thing. Know how to write loops. The only tricky thing about loops is the upper boundary, right? If you do this, for int x is equal to 0, x is less than, well, let's make it 1. How many things is that going to print out? Yeah, it's not going to print 10. Looks like it'll print 10, but it's really 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you wanted to make it go all the way to 10, you would change that to an equal sign. Some of these are quiz questions, so I'm not telling you them. Go back and look at your quiz. All right, the act of asking a question and then letting the user type something. What is that called?
Input.
Good term. But if I listed four names like declaration, assignment, prompt, or concatenation, which one of those sounds best?
Prompt.
You're prompting the user. All right, so naming conventions. If you see something in all uppercase, like speed of light, or max, num, or something, if it's all uppercase, what does that imply about the data?
It's a constant.
It's a constant, right? What if it starts with a lowercase letter, like, IN? That implies something about it, as opposed to something that begins, with an uppercase letter.
Primitive.
Yeah, if it begins with a lowercase letter, it's either a primitive or a variable name. If it begins with an uppercase letter, it's going to be a class name. Now, the C++ book has an error in it. It says that you cannot use a $sign in your variable names. I believe this language lets us. I believe both languages let us. Okay, so regardless of what the book says, maybe it says $signs are legal. $signs are legal variable names. Underscores are legal, right? How about letters and digits? Those are good variable components. There's only one specific rule, though. What can a variable not begin with?
No, a number.
Right, can't start with a digit. All of those others are fair game. What's the difference between declaration and initialization and assignment?
Declaration means you declare this.
Yeah, so I'm going to write several statements. Int x, int y is equal to 30, and z is equal to 40. Which one of these is an initialization? That one is an initialization. Initializing is when you both declare and assign. All right. Which one is a declaration? Well, strictly speaking, both of these are declarations, but this one has a more specific name, right? So if you had the choice of calling your dog either a chihuahua or a dog, you'd probably call it a chihuahua. So that one's the specific form, and this is a declaration. And which one is an assignment? That's an assignment. Again, you could argue with me that that's also an assignment, but the best term for that is initializing. So initializing is declaring and assigning at the same in the same statement. All right, this is in the text, but we haven't been able to demonstrate it in class because if I pop open the command prompt and I type Java C, it doesn't do anything. However, you gotta know it. So, how to compile a Java program? You don't just hit the green button. Java C. That's the name of the compiler. And then what's the Java virtual machine? The runtime engine. It's just java.exe rather than Java C. Remember when division rounds down and when it doesn't. If you have x is equal to a divided by b there's a specific time when it'll round down. When is that?
You would round down if A, B were ends.
Right. If A and B are ints, this will round down. That's the only time. If one of them is a float, if one of them is a double, whatever, it won't round down. And more technically, if both operands are ints, so the operator are symbols like star and division and so on. Operands are the data that the operators work on. If both operands to the division operator are ints, the result is an int, meaning that it's rounded down. That'll get you, because if you do area, or area is equal to 4 divided by 3 times pi r cubed, whatever, that's probably volume, and we're just about to stop. Right, if we had that equation, it's not going to work, it's not going to calculate the right value. And why is that? What is 4 divided by 3? They're both integers. So it's 1. Obviously, that's not what we want. You'd want to take one of these, or both of them, and make them floats. All right, I think, yep, we know that one. Know the difference between a sentinel, a user query, and a counter, right? Those are 3 ways of doing loop termination. And this is another one that's in the book, and we didn't talk about it because we can't run it from the compiler. But a .class file is known as bytecode. The .java file is known as source code. The compiler creates bytecode from the .class file. There's a possibility I'm going to remove that question. But really, you got to know this stuff. It's just that some of this stuff, I need to ask if the machines have their search paths operated. I'm going to delete that question. I'm going to delete that. Alrighty, get rid of that. Okay, so I think other than these things right here, if those aren't in a quiz, I need to put them in a quiz. And let me ask those of y'all who have the quizzes fresh in your mind. Are these questions in the quiz, any of the quizzes you took?
No.
All right. Well, now we know. Okay, so make it even easier. All right, yeah. You get a question about those, just look on the front page of our, because it's not only is it open book, it's open anything that's uploaded to D2L. Okay, gang. I'll see y'all on Thursday. Any questions? Nope. All right. You have a question?
Yeah.
Be more assertive. All
The
right.
quizzes, when you graded quiz 2, I could see my answer and whether it was right or wrong, but I can't for 3 and 4.
I need to fix that. You're always supposed to be able to see your answers. So thanks for pointing that out. Yeah, you're just supposed to take it again without knowing what you missed. Sorry. That wouldn't be fair.
Doesn't make it a good reference for the final year.
Yeah. All right. Please refresh your page and make sure that works.
It's showing, I think it's showing what I did, but not whether I got it right or wrong.
It's not showing the score. Which one are you looking at?
3.
Yeah. Foobar. All right, once more with feeling. Refresh and check again.
Now it's doing.
All right, apologize for that. All right, guys, our test review for Java went a little over time, so I'm going to be back at 8:35 rather than 8:30. Just warning y'all. Stop the recording. That's always a good thing.